In this video, we will look at adding fractions using number lines. This standard builds on the work students did in 4th grade, where they added fractions with like denominators. It also requires students to apply what they learned about finding equivalent fractions, since their work in 5th grade involves fractions with like denominators using related fractions. Related fractions are like what you see here with 2/5 and 3/10, in which one denominator is a multiple of the other. Students are also expected to use benchmark fractions to assess the reasonableness of answers, and they should have ample experiences using models to build understanding and to allow them to use reasonableness to find a common denominator prior to using the algorithm. Let's take a look at how we can add 2/5 and 3/10 using number lines. To get started, we'll estimate. I know that 2/5 is close to 1/2. I know that anytime the numerator is equal to half of the denominator, a fraction is equal to 1/2. And I know that half of 5 is 2.5, and 2 is close to that. So that lets me know this fraction is close to 1/2. 3/10 is also close to 1/2. It is just 2/10 away from 5/10, which would be 1/2, and it's 3/10 more than 0. So it is close to 1/2, and I know that 1/2 plus 1/2 would be 1/2. So I know that our answer will be around 1/2. I know it will be a little bit less than that though, since both of these fractions were actually each a little less than 1/2. So to begin to solve, we want to draw a number line. First, I'm going to represent 2/5. So we'll have 0 here, and then we'll split our number line into 5 equal parts. Okay. And then we will show that we have 2/5 here just by maybe making a bar to the point of 2/5. Now, there are different ways that students could use number lines to solve. I'm going to show one way here first, and then I'll show another way afterwards. So right below this number line, I'm just going to go ahead and also model the 3/10. So I'm going to draw a separate number line to show 3/10. So I'll split this one into 10 equal parts. And I'll label this so we can show the tenths. And there's 10/10 or 1/2. And now I'll just use a different color to show we know that we have 3/10 that we are going to add to this. So now we know that in order to be able to add these fractions, we would need them to have the same denominators. And when I look at these number lines, I see that our 5ths number line could actually be split into 10 equal parts instead of just being in 5 equal parts. That would allow me to look at the 2/5 in terms of tenths instead of fifths. So I'd be able to have both of these fractions in tenths. So I'll go ahead and split this number line into 10 equal parts now instead by just breaking each fifth in half. So now I could show, well, this is where 1/10 would be. I could see that 1/5 is equivalent to 2/10. Here would be 3/10. This shows me that 2/5 is actually equivalent to 4/10. There's 5/10. Shows me that 3/5 is 6/10. That 4/5 is 8/10. There's 9/10. And this would, of course, be 10/10 or 1/2. So now I can see that 2/5 is equivalent to 4/10. Since this first number line is now split into tenths, I could actually just go ahead and shade the 3 additional tenths on there. So I'm going to go ahead and do that in green since I did that below, but I can show 3 more tenths, and then I will have added the 3/10 onto the 2/5 that was already on this number line. So I can shade, there's 1 more tenth, 2/10 more, and 3/10 more. And I see that we end up right here at 7/10. And so that shows me that 2/5 plus 3/10 is equal to 7/10. When I think about our estimated answer, we thought our answer would be close to 1/2, but we knew it would be a little bit less than 1 whole, and 7/10 is pretty close to 1, and definitely less than it like we thought. Now, that was a way to look at adding using two different number lines. You could also just use one number line to add these two fractions. And this is something that students may be able to do as they continue to get practice with working with finding equivalent fractions. Possibly not right in the beginning, but what we would do is just show our number line. And I'm going to show my 2/5 again. So I'd have 0, then split this into 5 equal parts. So 1/5, 2/5, 3/5, 4/5, and here's 5/5 or 1 whole. And now we know that we have 2/5 to begin with. But now what we could think about is rather than even having to draw another number line, we can just think, well, I know that we need to add to this 2/5, we need to add 3/10. And when I'm looking at this fifths number line, I could see that this could easily be split into 10 equal parts if I just broke each fifth in half. And so I could just go ahead and do that right away. So split each fifth in half. And now my number line is split into 10 equal parts instead of 5 equal parts. And I would be able to add the 3/10 on. So I'll go back and label this would be 1/10, 2/10, 3/10. Here's where I can see that 2/5 is equivalent to 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and then of course here was 10/10. And so we can see 2/5 is equivalent to 4/10. And now that this number line is split into tenths, I could just go ahead and add on the 3 additional tenths. So 1, 2, 3, and that gets us to 7/10 like we had seen before. So we get the same answer, but we just worked with this one number line. So either of these options is perfectly fine. It's just two different ways a number line could be used to add fractions.